Welcome! It's great to have you here. You're creating history just by watching this video. By choosing to learn about the cosmos, you're joining a lineage of curious minds, stretching back to humanity's very beginnings. Since our ancestors first gazed up at the night sky, we've been driven by a deep desire to understand the universe and our place in it. Today we'll embark on an incredible journey, exploring one of the most captivating stories the universe has to tell, the life cycle of stars. Prepare to be amazed. Stars are the building blocks of the universe, massive spheres of plasma held together by their own gravity. They are the cosmic furnaces where elements are forged, the lighthouses of the cosmos. From our vantage point on Earth, stars might seem like unchanging points of light, but the truth is far more dynamic. Stars are born, they live, and they die. And their lives are anything but boring. These celestial giants evolve over millions, billions, even trillions of years, influencing the cosmos around them on an unimaginable scale. Their gravity holds galaxies together, and their deaths provide the raw material for new generations of stars and planets. Today, we'll journey through the epic life cycle of stars, from their humble beginnings in vast clouds of gas and dust, to their explosive deaths as supernova, or their quiet fades into darkness. We'll uncover the secrets of their inner workings, the forces that drive their evolution, and the profound impact they have on the universe, including our own existence. So buckle up, fellow space explorers. Our cosmic adventure is about to begin. Our story begins in the cold, dark depths of interstellar space where stars are born in massive clouds of gas and dust known as nebulae. These nebulae, often called stellar nurseries, are some of the most visually stunning objects in the universe. The Eagle Nebula, with its iconic pillars of creation, and the Orion Nebula, visible to the naked eye, are just two examples of these cosmic breeding grounds. Within these vast clouds, gravity acts as a sculptor, slowly pulling together clumps of gas and dust. As these clumps grow denser, their gravitational pull intensifies, attracting even more material. Over time, these collapsing fragments of nebulae heat up, forming what we call protostars, the embryonic stage of a star's life. The protostar, though not yet a true star, is a hotbed of activity. As it continues to contract under its own gravity, the temperature and pressure at its core increase dramatically. Millions of years pass and this gravitational energy transforms into heat, causing the protostar to glow brightly, illuminating the surrounding nebula. Eventually, a critical threshold is reached. The core of the protostar becomes so incredibly hot and dense that a new force ignites: nuclear fusion. At this very moment, a star is truly born. With the ignition of nuclear fusion, a star enters the main sequence, the longest and most stable period of its life. This is the stage where stars truly shine, converting vast amounts of matter into energy and lighting up the universe. Deep within the core of a main sequence star, hydrogen atoms are fused together under immense pressure and temperature, creating helium and releasing a tremendous amount of energy. This energy, in the form of light and heat, radiates outward from the star's core, counteracting the inward pull of gravity and creating a delicate balance that defines this phase. Our own sun, a yellow dwarf star, is currently in its main sequence, happily fusing hydrogen into helium and bathing our planet in life-giving light. It has been doing so for about 4.6 billion years, and will continue for another 5 billion or so. But not all main sequence stars are created equal. The lifespan and ultimate fate of a star are determined by its mass. Massive stars, much larger than our sun, may be incredibly bright and hot, but they burn through their hydrogen fuel much faster, living for only a few million years. Smaller stars, on the other hand, sip their fuel slowly, stretching their lifespans for billions, even trillions of years. As a star ages on the main sequence, its core gradually becomes depleted of hydrogen. This sets the stage for the next chapter in a star's life, a period marked by dramatic transformations and a shift in its cosmic influence. hinges on their mass. The death of a star is one of the most awe-inspiring events in the cosmos, a dramatic finale that depends largely on the star's mass. Some stars fade into darkness while others explode in a supernova. Stars like our Sun end as a planetary nebula. The red giant sheds its outer layers, forming a glowing shell of gas and dust. The core remains as a white dwarf composed mostly of carbon and oxygen. This remnant will cool over billions of years, eventually becoming a black dwarf. Massive stars end in a cataclysmic supernova. The core collapses, triggering a runaway fusion reaction. This explosion can outshine an entire galaxy. The explosion seeds space with heavy elements, building blocks of new stars and planets. Left behind is either a neutron star or, if massive enough, a black hole. The death of a star gives rise to some of the most extreme objects in the universe: white dwarfs, neutron stars, and black holes. These remnants continue to influence the cosmos around them. White dwarfs are Earth-sized remnants of sun-like stars, incredibly dense and hot. Over billions of years they cool and fade into black dwarfs. Neutron stars from supernova remnants are even more extreme. Imagine compressing the sun's mass into a few miles. They spin rapidly, emitting beams of radiation. If these beams sweep Earth, we see pulsars. Black holes formed from massive star collapse warp space-time. They distort light and influence nearby stars and gas. These remnants remind us of the cyclical nature of the cosmos. The death of a star is not the end, but rather a new beginning, a vital step in the grand cycle of cosmic evolution. The material scattered by stellar winds and supernova explosions enriches the interstellar medium, providing the raw ingredients for future generations of stars and planets. Imagine the iron in your blood, the calcium in your bones, the gold in your jewelry. All these elements were forged in the hearts of stars that lived and died long ago. We are, quite literally, made of stardust. Supernovae, those spectacular stellar explosions, play a crucial role in this cosmic recycling process. They seed the interstellar medium with heavy elements, enriching the clouds of gas and dust that will eventually collapse to form new stars and planetary systems. These new stellar systems inherit the legacy of their predecessors, carrying within them the building blocks of planets, moons, and even life itself. The cycle continues. Stars are born from the ashes of their ancestors, live out their lives, and eventually return to the cosmos, enriching it for future generations. It's a beautiful and humbling thought that we are all connected to this grand cosmic cycle, inextricably linked to the stars that light up the night sky. Thank you for watching. If you enjoyed this video, leave a like, comment your thoughts, and subscribe for more space discoveries. See you next time. As we conclude our journey through the life cycle of stars, remember this: the universe is a vast and ever-changing place full of wonder and mystery. There's always more to learn, more to explore, and more to discover. Keep looking up at the night sky, keep asking questions, and keep your sense of wonder alive. The cosmos awaits.